Hi there. Welcome to Computing Foundations. This is a channel for beginners who want to learn about programming, computers, and the math, science, and art behind this world-changing field. I'm Josh Kilpatrick, a retired software engineer. If you've enjoyed these videos, please take a second to like, subscribe, and share comments to help me improve this channel. You've reached the final video in our series of learning to program with the C language. This final video is about an important topic called file input and output. Up until now, we've only been working with the memory of the computer. We haven't really discussed a way to save data in the running program in such a way that we could access it again later after the program has exited. This is where files come in a computer, and we're going to learn today about how to write these files. The concept of working with files is beginning to kind of get just past the beginning concepts of working in the C language. I say that because there's a lot of nuances to working with files, and they can be a little different depending on what operating system you're working on. And the most important thing is that you learn to read the documentation for how the standard input-output library works on your particular computer. You can do that by searching online for stdio, stdio.h, and reading the documentation. Or a slightly more precise way to do it is to execute a man command, that's manual command, to look up the library and its functions specifically as they are installed on your computer. I'll show you an example here when we get to the coding portion of today's video on how to look up the manual files for a library installed on your particular system. Okay, let's dive in and learn about files. Okay, so to get you conceptually oriented, I want you to think about files using the following concept. So first of all, let's imagine that I am a computer and I have sitting on my desk a piece of paper. This piece of paper is a good analogy for the memory of a computer. Why? Well, much like the memory of a computer, if I have a piece of paper sitting on my desk, I can see the entire piece of paper all at once. I can look at and write on any line, any part of the paper that I want. This is similar to how memory works. It's directly addressable. I can go to any place in the memory instantly and see what's there. It doesn't cost me anything, any extra effort to look and to get whatever I want off the page. But one of the problems with memory, well, there's two problems. First, it's limited. I only have a reasonably small amount of it to work with. And two, it disappears, it gets erased when my program exits. I can't use that data anymore. It was only good while the program was running. Now, files on a computer are a little bit more like a scroll or a book. What do I mean by that? Well, I can store a lot more information in a scroll or in a book than I can on just one piece of paper. But there's a little bit of a drawback, and that is if I want to access data inside of a book, first I have to open the book and I have to go to the page where the data is before I can read it or before I can write onto that page. And the only way to get to a page in a book or to get to a page in a scroll is I have to kind of wind through the scroll or flip through the book until I can get to the place where I need to access the data. So this is a concept for how to think about files. We're going to open them and then we're going to move through the file until we reach the place that we want to read. Okay, so that's the basics of how to think about a file on a computer system. So the first function that we need to learn about is the fopen function. It stands for open a file. Now, the signature for the function looks like this. This special return type is a structure. This structure is defined in stdio.h. And it isn't that important what's inside the structure. You can go look if you're curious. But the structure is used to represent an open file that's available for you to read and or write. So the fopen function will return a pointer to a file structure. What do we have to give the fopen function as parameters? Well, first we have to give it a file name. Now you can write the file name as a complete path all the way to the file that you want to access, or as a relative path in relation to where the program was executed. So this is called the working directory of the program. You can experiment with this in the number 16 program that goes along with this video by changing where the files are, changing the paths that I'm using to reference the files. It might take a little bit of time to get used to it, how you would write a relative file path. You have to understand where will my program be running. And the last part of the fopen function is a mode. So I've written here a quick primer on the mode. The mode is just a string that contains a set of characters that describe to the file open command, what do I want you to do with this file? Now, keep in mind, if I'm opening a file, there's a couple different possibilities. Maybe the file already exists. Maybe it doesn't exist. So what do I want the computer to do if I ask it to open a file, but that file doesn't exist? Well, this is what the mode is going to describe. So let's get started. If I put an R for the mode, I'm telling the computer two things. First, I want you to open this file for reading, and if the file doesn't exist, I want you to fail. So I'm checking to see if the file exists when I put an R in the mode. And I'm telling the computer, I only want to read out of this file. Okay? What if I want to write into a file? Okay, I can say R+. This means the file must exist, so if it doesn't exist, fail. But I might want to read into the file or write into the file. It's my prerogative. That's what R+ means. W means I want to open a file and I'm only going to write into the file. I'm not interested in reading anything. So by definition, it means the file is expected not to exist. I'm opening the file to write into it. It can't already exist, or I can't open it and write into it. So the way this function works is, if the file you're asking for already exists, it will be erased. And it will be like you're opening a brand new file for the first time. So you use W when you want to write information into a file and you don't care if the file already existed. You just want to delete it and overwrite it. W+ means the same thing, except you can write to the file or you can read from the file. You can do both. A is the final mode, and it means I want to append to an existing file. So R means I want to read an existing file. Write means I want to write to a non-existing file, or if the file does exist, I want you to blow it away and let me write to it new. Append means I'm expecting this file already exists and I want to add to the file. So I can say if the file doesn't exist, it will be created for me. That's the way the A mode works. But if it exists, it will be opened and it will be prepared so that I can write just to the end of the file. Okay? So I'm not going to erase what exists in the file. I can now add to the end of it. If I put a plus behind the A, I am saying, look, I might want to read what's in the file as well, but I'm only going to be able to write to the end of the file. Okay? Lastly, there is another specifier, a B, which you can add to the end of any of these modes. And it means binary. It means I want to write into the file in binary mode. Now, on many computer systems today, whether you put a B or you don't put a B isn't going to make any difference in how the computer uses and writes to the file. But it's good practice that if you're not going to be writing strings of characters into your file, then to specify that you're writing a binary file, meaning this isn't the kind of file that a user can open up and read text in the file. It's just a bunch of ones and zeros. Now, really, all files are just a bunch of ones and zeros. So what's the difference between a text file and a binary file? Well, it's just a convention. Text files only contain characters that are 8 bytes of data encoded as a character, and it has lines, and each line ends with a new line character, so that you basically write a bunch of text and then you have a \n at the end of it for the next line. That's a text file. A binary file doesn't make that guarantee that it's going to always contain characters. All right, the next function you need to understand is fclose. It's very simple. When you're finished working with a file, you need to call close and give the file pointer to the fclose command, fclose function. This is going to flush all the data out of the buffers, write your file correctly, and close it so that it's ready for the next use or ready to be opened later. Text files versus binary files. We'll just go over this one more time. So text files contain lines of encoded characters terminated by sometimes just a new line, sometimes a new line plus a carriage return. Now, depending on which kind of computer you're working on, whether it's an Apple computer or a Unix computer or a Windows computer, different operating systems have different conventions for how they terminate new lines in text files. So you just have to understand how your computer works, and we'll talk in the example program about how to do that. Binary files only contain bytes, so that means there's no definition of what's in the file except what the programmer intended. It's not any guarantee that it's going to be something you could decode as text. It's just bytes. All right, so let's talk about the functions that you're going to use to write text to a file. Okay, the most popular or common functions you'll be using are fgetS to get a string out of a file, and fputS to put a string into a file. We've already learned about how these functions work. The file operator here, the file parameter here should be the file that you've opened, and then you're just going to say, here's my character array that I want to store data into, and I want you to read X number of characters out of the file and store them in my character array. Now, fgetS will stop reading if it hits the new line. So it's only going to read up to one line or the number of characters you told it to read. As another example here, you can also use the function fprintf to write a string to a file in a way that's formatted. So this is saying, hey, I want to encode different variables into my string, and that's when I would use fprintf. Using fprintf is similar to setting up a character array, using sprintf to write a string into my character array, then using fputS to put the string into the file. So fprintf just gives us a shortcut for formatting a string and writing it into the file all in one step. Okay, you can also use fscanf to read data out of a file instead of using fgetS. You might choose to do this if you have written numerical values into your file in text format. So if you want to read those numerical values back out of the file and turn them into integers, floating point numbers, etc., fscanf can help you do that. Now, I said at the beginning of the video, we're getting to a point where I'm not really teaching you about the fundamentals of C programming anymore, because in different systems, you need to read the manual files about how these functions work. There's a lot of different nuances to how these functions work. And rather than trying to teach you every detail, what you need to learn is how to read the manual files for how these functions work on your computer. Let's take a second now to just show you how you would read the manual files. So I'm here inside my program editor, and what I'm going to execute is the man command, and let's just put here fprintf. That is the function I was just discussing. Now, as you see here, it opens up Library Functions Manual for printf. And it says here, okay, printf has a bunch of different formats. One of the formats is fprintf. And here is fprintf, and it describes to me what are the different variables in fprintf. If I hit enter, it'll bring me to the next page of the manual file, and I can begin to read all about how these printf functions work. And as I move through this manual entry, I can find examples and details about how to use the functions. So you need to get comfortable with, if you don't know how a function works exactly, you can look it up online or look it up as a manual file on your system. Okay. So we went through writing text. Now, how do I write binary to a file? The two functions of import are fread and fwrite. And the way they work is, if you want to read binary from a file, you provide a pointer to an area of memory that you've reserved. This could be an array you defined statically or a piece of dynamic memory that you've allocated. Next, you say, I want to read chunks out of the file of a certain size. So if you want to read integer data out of the file, you would say size of int. If you want to read a structure out of the file, you'd say size of structure. If you want to read a character out of the file, you'd say size of character. And each of those are going to represent a certain number of bytes. Then you say, how many of these do I want to read? So if I put an 8 for size, saying I want to read, if I put a 1 for size, saying I want to read 1 byte, and I put a 2 here in the count variable, I'm saying I want to read out 2 1-byte blocks of the file. So first I define the size of what I want to read, how big is a record, and how many of those do I want to read. And then I give it the pointer to the file. And the fread function will take the current location in the file, it will read out the data you've asked it to read, store it into your pointer, and then return. If it fails to read what you've asked it to read, it will tell you, it will return what count of data was it able to read out of your file. So you can check to see how much did it read. So what's important about this is you're just reading bytes, so you have to know what's in the file. But if you're the programmer and you wrote the file, you know what you've placed in it, and you need to read out of it in the same order that you wrote into it. Fwrite functions just like fread with the same parameters. You give it a pointer to data that you've populated, you tell it the size of your elements, how many elements, and out it goes into your file. So you might have noticed up until now, we open a file and then it's almost like we have a pointer to the beginning of the file. If we start reading or writing, we're going to be moving forward in the file, either reading what's already there or writing into the file. how do I get to a certain place in the file? If I don't want to read from the beginning, how do I jump to a location in the file? Well, the functions that are provided for you are fseek, frewind, and ftell. How do they work? So you can think of a file as a big, long array of data. If I say fseek and I give it an integer or a number, I'm telling it I want to move forward from wherever I am right now, wherever the file pointer is. If I just open the file, then it's at the very beginning. It's at the 0th byte. I want to move forward by a certain number of bytes. So if I say fseek, I'm not going to read any of this data. I'm just going to move the file pointer forward a number of bytes that I've specified. If I want to get my file pointer back to the beginning of the file, I put frewind. That'll move me back to the beginning. And if the file pointer is already somewhere in the file, I can use ftell to tell me at what offset in the file am I currently? Where am I currently? So in order to jump to an area of the file, I seek. To get back to the beginning of the file, I rewind. And to ask where am I right now in the file, I use ftell. So these are the basic concepts of working with files in the C programming language. As always, we have a nice coding exercise ready for you in file number 16. Go through that, play with it, experiment, and this brings you to the end of our series in learning the basics of C programming. Congratulations. The videos that will be coming next will be more detailed videos about different programming concepts like algorithms, data structures, multi-threaded programming. I'll look forward to teaching you more about these more advanced concepts in future videos. I hope you've enjoyed this series on learning to program in C, and I wish you all the best.